So the next concept is sum of all interior angles of a polygon. Okay, so in the previous class we discussed up to that number of line segments, how to calculate the number of line segments and the number of diagonals, right? So in this class we are going to discuss about that how to calculate that total angle. Okay, total angle means the sum of all interior angles of a given polygon. Okay, so here we can use that the formula is 2n minus 4 into 90 degrees. By using this formula we can find that sum of all interior angles of any polygon. Okay, so let us see that. First see that how we got this formula. After we will discuss that how we can use this formula. Okay, so see that. So I am going to take that the first figure is a triangle. Okay, so in this figure we have that how many angles? We know that in a triangle we have that 3 sides and 3 angles. 3 vertices also there, no? So here we have that 3 angles. How many angles are there? 3 angles are there. Here I am going to take those angles as theta 1, theta 2, theta 3. Okay, here I taken 3 angles. Those 3 are theta 1, theta 2 and theta 3. So here sum of these 3 angles is equals to theta 1 plus theta 2 plus theta 3 is equals to 180 degrees. We know this, yes or no? We know this condition, right? Sum of all interior angles of a triangle. From that 6th class onwards we are learning this one. Okay, sum of all interior angles of a triangle is 180 degrees. Next, for example, here I am going to take that quadrilateral. Okay, so this is theta 1, theta 2, theta 3, theta 4. So here this is a quadrilateral. Okay, in this quadrilateral how many angles are there? Here we have that 4 angles, right? So what are those 4? Theta 1 plus, theta 2 plus, theta 3 plus, theta 4. So here we have that 4 angles. What are those? Theta 1, theta 2, theta 3, theta 4. If you add these all angles, we will get here 360 degrees. Yes or no? Okay. Why? Because 90 plus 90, 180. 180 plus 90, 270. 270 plus 90 is nothing but 360 degrees. This condition also we know that. Okay. After that onwards, if you don't know, then we can use that formula. Okay. But we know these 2 conditions, right? What are those? Sum of all interior angles of a triangle is 180 degrees and sum of all interior angles of any quadrilateral, okay, that is equals to 360 degrees. We know these 2 conditions, right? We know that these 2 conditions we know. So here 180 degrees, we can write this one as 1 into 180 degrees. Shall we write like that? 1 into 180. And this one we can write it as 2 into 180 degrees. Here I am taking that one as 180 as common. Okay. This is 180 into 1 is equals to 180 and this is 180 into 2 is equals to 360. Okay. Why I written 1 here like this means 1 we can represent as number of sides of this figure is 3 minus 2. Shall we write like that? Okay. Number of sides of a given figure. Okay, that is equals to 3. 3 into how much is equal? 3 minus how much is equals to 1? 3 minus 2 is equals to 1, right? So 3 minus 2 is equals to 1. So and in the same way, 2 here we can represent it as number of sides of this figure is 4 sides here we have. So 4 minus how much is equals to 2? Okay, so 4 minus how much? That is equals to 2. So 4 minus 2 is equals to 2. Okay, 4 minus 2 is equals to 2. Is it clear? So we can represent that 3 minus 2 and this is a 4 minus 2. Shall we write like that? Okay, so we can represent this one as a 4 minus 2 into 180 degrees and this is 3 minus 2 into 180 degrees. Is it clear? And in the same way, for example here that is n-gon. That is n-sided figure. That is n-sided figure. Then sum of all interior angles of n-gon is. How we can find that? Yes, and in the same way just observe that this is number of sides only, no? And here also number of sides minus 2. into 180. So number of sides here, number of sides is equals to n. So which is nothing but equals to n minus 2 is in common. Just observe that here also 2, here also 2. So next one is 5 minus 2 into 180. Next is 6 minus 2 into 180. If that is a 7-sided figure, then 7 minus 2 into 180. Okay. So here in this one n minus 2 into 180 degrees. So what is that formula here to find that sum of all interior angles of a polygon? What is that formula here? That is n minus 2 into 180 degrees. But here I written that 2n minus 4 into 90. How we got that? This one only we can represent that n minus 2. Okay, 180 degrees we can write it as 2 into 90 degrees. Shall we write like that? Here we can use that right angles also. So that's why 2 into 90 degrees is nothing but 180 degrees. So 2 into n is equals to 2n minus 2 into 2 is equals to 4 into 90 degrees. Just I multiplied these two terms, n minus 2 into 2 which is equals to 2n minus 4, okay, into 90 degrees. Is it clear? So here the formula is 2n minus 4 into 90 degrees, or we can write the formula as n minus 2 into 180 degrees. So those two also same, only those two also correct. Okay, we can use that any one of the formula from that. After taking that common thing, okay, we got that n minus 2 into 180 degrees. Without taking any common, just we need to write that one means 2n minus 4 into 90 degrees. Okay, so once again I am saying that sum of all interior angles of a polygon. So here the formula is 2n minus 4 into 90 degrees or n minus 2 into 180 degrees. This is very important formula. Okay, now we will see that how we can use this formula. Okay, so in a triangle I am saying that 180 degrees. No, here also we can check that by using this formula we can check that sum of all interior angles is equals to 180 degrees or not. Okay, so see here, let n is equals to 3, then sum of all interior angles. What is that formula? 2 into n minus 4. So at the place of n, just substitute that number of sides. N is equals to 3 minus 4 into 90 degrees. So which is equals to 2 into 3 is 6 minus 4 into 90 degrees. So which is equals to 6 minus 4 is 2 into 90 degrees. So which is equals to 180 degrees. So we know that sum of all interior angles of a three-sided figure. Three-sided figure is nothing but a triangle. So in a triangle, sum of all interior angles is equals to 180 degrees. Okay. So next one, for example, take that n is equals to 4. Again the same process, 2 into 4 minus 4 into 90. So to 4's 8 minus 4 is equals to 4 into 90, which is equals to 360. Okay, for example, n is equals to 5, which means that is a pentagon. Pentagon means n is equals to, that is a 5-sided figure, right? So in a pentagon, sum of all interior angles, then how we can find? Use the formula 2 into n minus 4 into 90 degrees. 2n minus 4 into 90 degrees. So 2 into 5, that is 10 minus 4 into 90 degrees. So 10 minus 4 is nothing but 6. So 6 into 90 degrees, which is equals to 540 degrees. So sum of all interior angles of a polygon, what is that? Of a pentagon is 540 degrees. Is it clear? Okay. So like this way we can find that sum of all interior angles of any polygon. If that figure is consisting of 10-sided figure, then 2 into 10 minus 4 into 90 degrees. So 2 into 10 is nothing but 20. 20 minus 4 is 16. So 16 into 90 degrees. So we will get that answer. Okay. So 69 says 144. So 144 and 0. 1440 degrees. Sum of all interior angles of a decagon, which is equals to 1440 degrees. Okay, so by using this formula we can find that if you want this formula, if you want to use this one, n minus 2 into 180, is it possible or not? See here, n minus 2, for example, n is equals to 10, 10 minus 2 into 180 degrees. So 10 minus 2 is 8, 8 into 18. So again you will get the same result, that is 1440 degrees. Okay, so this formula also we can use. So either the formula is n minus 2 into 180 degrees or 2n minus 4 into 90 degrees. Any one of the formula we can use here. Okay.